All right. Hey, everyone. This is the KMS meeting for January 18th, 2022. This is the fourth KMS meeting in the series. So we were just continuing the discussion on how we want to frame versioning and GA requirements and such for the KMS cap. So trying to remember my train of thought and issue exactly what we were on right now. Remember?
I think we were talking about the audit ID, whether or not we want to use that as a GA gate.
Yeah, right. So right now the initial cap document does not have graduation criteria because it's not a Kubernetes REST API, and what we're proposing is basically just one minor optional additional field that doesn't have to be persisted anywhere. It's just up to the KMS to consume it if it wants to. So that one's a little bit harder to frame. Sorry, go ahead.
So I had commented on Damien's point about that. I think there's having the audit ID there is useful, but given that there are requests that don't have the audit ID generated, I failed. Like it's in some cases, this wouldn't be quite useful for what we need in terms of correlating. So if that's the case, meaning it doesn't cover 100% of all the cases, then I really want to make sure that is not part of the GA gate, because I mean, I guess like I don't even know if it makes sense to include it if it doesn't cover like all the cases where we need correlation. I think it's a nice to have if you want to use audit ID for this, but it doesn't cover all cases. So I don't think we should include it.
If I can ask something about that, like,
go ahead.
By saying that it doesn't cover all the cases, like, do you mean that some of the operations, since they are writing the cache, we don't have an audit ID on the KMS side, or is it something different?
No, it's something different. Let me pull up the. It was something that Mike brought up, right?
Yeah. So he's saying that as we the API server, when it starts up to fill up the watch cache, we'll do a full list on all secrets and all API resources, right? And at that point, it will cause it to cache data encryption keys in its storage layer, right? So later on, when users are actually getting those secrets, you won't see those events in KMS at all, right? So those are unknown. And then that list from the API server also itself doesn't necessarily have an audit ID because it's just the API server talking to itself. So the more I've thought about it, the less I feel like we should do anything with audit ID, because it'll always be a maybe API.
Right.
And to me, it might make more sense to pursue the audit annotations approach, which is to actually include the KMS UID as an audit annotation within audit logs. So if an audit log is generated and it happens to also have a KMS event occur, then the audit event will tell you about that. So you can search for it if you want to. But
yeah.
But the
inverse is not true. Yeah, the inverse.
Yeah, because the inverse is not true. Let's just don't worry about it.
It's not useful, right? I mean, we could try to add it, but it's not going to cover all our bases. And just to clarify, like what Mike said was initial load is not audit logged, but does trigger KMS calls, right?
Yeah.
So in which case we will get
why
the
is that the case? Because if the KMS is involved, like how come the audit log is not produced?
So not every request from API server to KMS is initiated by a user request, right? So when an API server restarts, it basically has to warm up its cache.
Right.
So it's just going to make calls just to update its cache, and then that is not correlated with any request from the user.
So from that perspective, this new UID is way more useful because we can actually correlate them. Right.
Yeah, that might be kind of a topic for another thing, but like how come requests that are made by the API server to, let's say, in our case, it's a KMS, but in some other cases, it might be an aggregated API. How come these requests aren't logged? Like, what is the actual like reasoning for that? Because to me, whatever the operation is, as long as it goes from one point to another, even if it's made by the API server, we would want to track it.
Right, but these are low-level storage calls, right? These are not part of the Kubernetes REST API. That's why. Right, this is the storage layer being the storage layer, right? It doesn't go through the Kubernetes API because it implements the Kubernetes API.
Yeah.
Right.
Yeah, makes sense.
So, right. So that's kind of the gist. We do try very hard in the Kubernetes code base to go through the front door, which is to go through the Kubernetes REST API. But you can't do that everywhere because you can't implement the REST API without talking to storage directly at some points, right? So I think that's the general gist of it. But for example, we would never talk to an aggregated API through some back door because we wouldn't know where it was. We only know of the service to talk to.
Yeah, makes sense. Yeah, I was doing it at the REST level, but that's not the case.
Right. So I don't know if we want to, like, if we want to have the audit log have an audit annotation at some point with the KMS UID, that would need to probably be in this KEP somewhere, right? As a thing that happens at some point in the future, I guess. I mean, it doesn't have to be like the initial implementation or whatever, right? But it's probably worth calling out to see if people are okay with that as a future step, right?
Yeah, I think that's where I was a little confused. Should we add it if we still don't know if we're going to use it? Or can we add it at a later stage? Like, so this part focuses on what we are starting with. And then can we keep updating the KEP with newer things before we say it's completely done? So like at some point after investigation, we think the audit ID annotation is something we can do. Then at that point, do you think we can add it to the KEP as a PR and then just implement it?
Yeah, so what I would want that to happen, but my experience with the enhancements repo has told me that that's not how the enhancements leads and others want this to work. Because for example, with the addition to the CSR API, I just tried to update the existing certificate signing request KEP with the details of it, right? Because it was sort of all there. And I wanted to keep that KEP as a complete reference of like, well, this is what the CSR API is. And they're like, no, this KEP is implemented. This KEP is done. You have to make a different KEP to talk about effectively your 5-line change to the, right? It has to be completely isolated and tracked on its own. And I was like, okay, right? And I got like I remember Mike being like, really, that you have to do that much work to like do this tiny change? I was like, yes, the KEP is significantly more work than the code. So I would be very hesitant to say that it would be okay to say here's a KEP and like we did the UID stuff and that work is done. Now we can just go update it to add more stuff about what we now want to do with this UID. And because I think it's very hard for them to track, right? Like the idea of a KEP that doesn't go through the phases, I think immediately will raise a bunch of red flags for them and be like, what do you mean?
Yeah, the way I saw the KEP was it's like a design implementation noted down and like basically like discussed before we do it. And
Right.
that's why like it doesn't fall into any of those categories of graduation, right? And then if we add something and don't do it, are we allowed to take it out later? Like, let's say whatever we're investigating turns out that it's not possible to implement. Then at that point, even if it's we can't change it to implement it, but are we allowed to remove it from the KEP?
I mean, so I've certainly like, if for like the client go credentials plugin, like when when I took that cap over, I rewrote significant chunks of it because what had been implemented had significantly diverged from what was in that cap. And so, I was like, there's no point in this cap existing in the state. It's just confusing because it says one thing, but the code does another thing. So I think that part is okay. I didn't really get pushback on that. It's more of taking something that was considered done and then saying, I'm going to add stuff to it. Now it's not done anymore and thus needs to be tracked is a little more like if we're going to go from a document that doesn't have any phases to a document that does, I suspect they're going to ask us to make two separate documents, like one with the phases that is going to go through it with its own criteria, and one that was just a point in time, like KMS UID Cap that just said, we would like to add this UID, here's why, and here's how we're going to guarantee all the things. But like, we're just going to do it and it's going to be done. And that's it. Like that document is just sort of done then.
Okay, quick question, right? So if we don't move it to implement it, then are we allowed to update the existing cap with newer things that we're adding? Because even now, if we add that in the future, we are looking at audit ID, that means we cannot move the cap to implement it until we do that, right? Because we have said in the cap that we're going to do it. So instead, can we keep the cap in the provisioning state or implementable state, and then like keep updating it and keep adding new stuff, and then implement it? And then once we feel observability as a story is done, can we change it to implemented?
I think the answer is yes, but I think the weird part there is we need to have like what we're basically saying is we want to keep working on the cap and defining what it means for observability to be done. But the way the enhancements repo is framed is you define everything you plan on doing at once and then assign alpha, beta, and GA requirements of all of that, right? And that's where I think the disconnect is. I think the process for the enhancement repo expects you to know everything you want to do, and you're allowed to make mistakes and fix things, and that's fine. But you can't. I don't think you can change it as much as I think we're trying to change it. Right? Like we're saying that this is the piece where like basically what I think I'm saying is instead of having an observability cap, we might just have like 2 or more tiny caps related to KMS observability. And I think that fits within the mold of what the repo wants or the process wants us to do.
Yeah, that makes sense, because if we, in the future, if you want to do audit ID annotation, if you want to add implement details and motivation and all that, it just turns out to be a whole new cap.
Right, because it's basically unrelated, right? It's like, hey, there's this cool UID, but I want to show up somewhere else. Here's why.
Yeah.
So I mean, I think my thought process would be is we certainly want, like, for example, Clayton's like the only approver for encryption at rest left that still works on Kubernetes. So we would certainly want, like, and Clayton's an API reviewer too, so we can ask for his feedback on like how we should frame any of this, and same with like Jordan or Mike if anyone has opinions. I think I would be okay with just saying that this cap will go from, like, when it merges, it will be implementable. And then once the work is done, like, we're going to enumerate all the work related to this UID, and we're just going to say it's implemented, and that's it. Like, this cap will then just be done. And then next time we want to make a change, or next time we want to make an enhancements related to KMS observability, we'll just make a new cap that defines all the things that we want to do there. I think this one should be relatively small then, right? Like or I think it is small. When I was scanning, it seemed pretty small. The other thing I wanted to ask, more related to implementation, is Anish, did you go into details about how we're going to guarantee that this UID is available in like the Kubernetes logs?
I mentioned that we will log it in the API server as part of the changes that we are making. So I said for every request that we are logging for KMS and also additional logs that we add, we will add UID as a key to the log.
I don't think that answers kind of what I want, which is how do we guarantee that this basically how do we guarantee that this persists over time, right? Like over changes, right? Like as we go work on other things, right? Like related to KMS or whatever, how do we guarantee that those things have this? Like the closest I can think of is, so from the perspective of the storage API, or the internals of the storage API, this is represented as a transformer. And I think the transformer takes in a context, like not a Go context, but like a encryption context.
Mhm.
And I think what we might want to do is put the UID in there and then write a wrapper implementation of the transformer whose entire purpose is to always make sure that that UID gets logged, right? Along with anything else that we think is valuable as context. But like, I think if we did it that way, we have a pretty strong guarantee because we're just doing it from the outside of the transformer layer, just saying like, this is going to happen. It doesn't matter if the rest of the layers remember to do that, as long as they log the error itself or whatever, it's going to be in there.
Yeah, I can add that detail. Yeah, I didn't go too specific into the implementation. I suggested where we're making the optional fields and all of those, but I didn't go into detail on how we are implementing it, but I can add the transformer stuff there.
Yeah, I think we, I think we need at least a little bit more, right? Yeah, so right now I'm looking at it. The transformer interface has transform from storage and transform to storage, and you know, to take the data in, and then the second argument is a context, which today only has authenticated data, which I believe is the path to etcd. So we could expand that to include whatever metadata that we want, and then have like a wrapper implementation that guarantees that it's logged appropriately on failures.
Yeah, and then probably also success, right? Like just at a higher log velocity.
Yeah, probably significantly higher, but yes. Yeah, I guess errors could always be logged in, I don't know, whatever V makes sense, 6 or 8 probably, something like that.
Good, I can add that detail in the cap.
Okay. I think once we have that, and you know, I'm assuming, you know, we've enumerated our motivations and stuff, which I think are pretty straightforward. You know, I see a thing in KMS, I don't want to sit there and look at timestamps inside of API server logs and guess. You know. Oh, I think when I scanned it, I had seen something about like the name of the object or something like that somewhere in the cap. So for the gRPC API, all we're saying is we're going to pass in the UID, right? So I think that's totally cool. I think that fits within the intent of that API, which is to basically give the plugin the least amount of data possible for it to do its job. I think we're fine if we want to log more stuff on the API server, like the name of a secret and stuff, because the API server logs already contain all sorts of stuff like that. I don't think that's a big deal.
Yeah, I think that's what I added. I said like API server can log with some additional metadata that it has.
Yeah, so it would be good to enumerate what we want, right? So I think what we want is group version resource and name, right? Group version resource allows you to get a full location, and then the name pinpoints that location to a particular item, right? Yeah, and these are all on individual items, right? So that would be enough, right? You could say this secret and this. Oh, sorry, you need the namespace as well.
Namespace, yeah.
So do you need 5 things or 6 things, right? The GVR, namespace name, and the UID. Those
Right.
are so. But yeah, all of that would be good to enumerate, because then it would be clear to like Clayton and Jordan and whoever else wants to review this, that like, and also I think we have Sagoth tomorrow, right?
Yeah.
So I think we have enough, like we can talk about it tomorrow, the specific details, and maybe even bring up the oddities around fitting this within the enhancements report, or we can just say that we want to just basically have this bit of the KEP just go GA as it's implemented, because all it is just adding this thing, and see what people think. And if people think, no, that's weird or unexpected, then we basically have to add a feature gate that says, like, if you opt into this behavior. It'd be very strange, but
Yeah.
it is what it is.
Cool. I'll add these today, so it'll be up for review again. So hopefully we can all do one more round of review before the SIGOT call tomorrow.
I've been talking a lot. Does do other folks have comments?
Do you want to talk also about other topics like the performance topics, and or would you just like to focus on? Okay, I see a lot of nodding. Okay.
I'm totally cool with that. Are we done talking about observability? Just want to make sure. I don't have anything else. I just wanted to
If
make
we
sure.
just focus on UID.
Yeah.
Yeah, I think we have long-term action items and also like the immediate ones for the KEP. So I think that's a good place for us to transition to performance now.
Okay.
Just one thing I'm wondering, maybe, since the main focus will be the ID with the log, would it make sense to move the addition of metrics as a library to beta, so that at least like we have one focus for this release, and then for the next one, for like, yeah, for the graduation, then we have another focus?
I don't think I fully understood what you meant by beta.
So like there will be different graduation phases, as we've seen, and you mentioned that we, like, at first we didn't really know where to put the audit ID, if it ever was like supposed to live in this particular KEP, and since like we wanted to add metrics as a library, like should we still consider to do that for this release, or should we push that to another one?
I mean, what I'm understanding from our framing is that it would be a different KEP.
Okay.
Or Damien, are you more asking, like, once the UID is there, how is it actually going to be used?
No. I'm more saying that as part of the observability improvements, one thing we wanted to do is introduce a library for, like, to provide generic metrics in both Prometheus and OpenTelemetry format,
Right.
that an implementation could use. And I'm wondering, like, if it's part of the scope of this particular KEP, if we should even consider it like to be done at some point later, or if it should be done in another KEP.
Right. So like the reference implementation.
Yeah, exactly.
Yeah, that's what I meant by how it's actually going to be used, because we're adding it, right? But how it's actually going to be surfaced is where the metric stuff, the library comes in. That's a good question. I mean, do we want to
related to the logging?
Do we want to commit ourselves to say the reference implementation is part of the KEP graduation?
I don't think so. I don't even think we need a KEP for that, because like at the end of the day, we just introduce kind of an implementation, which like we think is a reference, but like nobody has to fully implement it, or even like they don't need to abide to our standards. So maybe we don't even need a KEP for that.
I think we might still need at least some part of a KEP because it will become like a SIGAUT subproject.
Yep.
Sort of be within our example repos and stuff. So, yeah, I think it would probably be part of a larger KEP related to some aspect of KMS, whatever we want to make it part of, or it might be like a mini KEP on the side related to other KEPs, basically, which is like, if we have like a performance one and an observability one, both of them could have beta requirements that say that like you need that implementation to be done, right? Like basically it's like a dependent of that other thing.
Yeah, that would make sense. The only problem I have with like how we are proceeding is that it's something I mentioned on the KEP, but we are basically trying to solve how we can correlate the data once like we've noticed a problem. But we have currently like no ways to actually detect that an operation failed or like something happens. Like we don't have the metrics that surface this information today. I'm not sure how users are currently able to notice issues, but as far as I can tell, like it lacks information.
Yeah, I think right now it's very provider specific. Like for instance, for Azure, like we have metrics around it, right? When KMS operations fail, and I'm assuming like other providers also do the same, where they generate metrics for failures in encrypt decrypt operation. But maybe we can have metrics on the API server to like aggregate these and say like, hey, look, encrypt calls are failing or decrypt calls are failing.
Yeah, that could be a good thing to tackle for this particular KEP, because at least we'll have like something shared by all the implementation that will surface issues. Let's say like with not that much information, because you can't really know like what exactly happened, but you are at least aware that a decrypt or an encrypt operation failed. So that can be surfaced as a metric. And then have maybe another effort that would provide a reference library to like provide metrics, but on the KMS provider side, not on the API server itself.
I don't have a strong opinion. I don't think it's a bad idea to say that this KEP should, like within the production readiness review questions, there is stuff about like, well, how does the cluster admin or the administrator observe the system is working? And so we're improving that by saying that we're gonna have better logging, right? But like it explicitly says in the PRR questions that logging is like the absolute last thing. Can you like come up with something slightly better if, right? So if so if we want to have metrics, we could define those within the KEP. Metrics are weird because they only exist at two stages, alpha and GA. There's no like middle.
That will change hopefully in the future, but
so hopefully we
and stable
because people think they can remove the alpha ones that have been sitting around for like 5 years, and I was like, no, you can't. It's effectively
we're trying to deprecate them in that case.
Yeah,
I understand the feeling. But I can help with that I can provide you some metrics that could be useful tomorrow, if you want.
Anish, Rita, Christoph, any of y'all have any thoughts about adding stuff to the KEP related to metrics?
I think if we can define with what metrics we want to add, maybe we can do that. That's fine. Like Damien, if you're interested, you can actually just open a PR to my KEP branch, and then we can just merge that and that'll show up. But if we don't have it, I think that is also fine. I'm just saying like we don't have to block on it. If we don't have it, we can always add this as part of the reference implementation KEP. We can say like, hey, we are introducing these metrics in KMS, and then we are also providing a way so you can consume it in your KMS plugin with the reference implementation.
Yeah, I agree. Sounds good. I don't have anything else on the observability side.
Cool. So I think we still got 15 minutes or so if we want to talk about performance stuff. Does anyone want to lead that and have strong opinions and thoughts? If anyone has the doc, do you want to share their screen? I don't have it right now, and my computer's in a weird state because I've been out of office. But I can make folks co-host if anyone wants to share.
I could share if no one else wants to share. Or Anish, you want to share?
I can try to share.
I'm on Linux. I always try to avoid sharing anything, as it usually causes a lot of trouble.
You all see my screen?
Mm-hmm.
Awesome. Okay. Yeah, I think in performance, like there were a couple of smaller topics that we had written up, right? So like the first one was basically cache warmup today. If the API server restarts, the thing is, because it makes a list API call, it makes a single call, decrypt call for every single secret that it has, and it wants to update the cache. It's calling sequentially, and then this means there's a burst of calls, right? And then at this point, your KMS will hit a rate limit. And then because API server keeps retrying, like your KMS goes into like some kind of a jail where it cannot recover, or basically every call is failing. And then when API server cannot warm up its cache because these operations are failing, it will fail all the health check and all that, and then it'll just keep restarting. So like I think the first one was that use case where how do we optimize this scenario? Because if you set a really large size for the cache size, the API server, when the API server is running, it's really helpful because not all calls are made to KMS. But if by chance your API server restarts, then you're basically like hit, like now you cannot recover at all. And then I think it also becomes worse when you have more, I mean, if you have multi-master scenarios. So like if you have aggregated API server, if you have 3 replicas of the API server, then each one is trying to warm up its cache.
Yeah, so I think today the recommended approach for like larger environments with a lot of encrypted data through a KMS is to explicitly configure your API server health check with the parameters that tell it not to care about the KMS part. Like, so basically check all the other health checks, but skip that one because it's just like, this is not worth it. Which obviously is silly, right? Like the point of the health check is the system healthy? And you're like, no, I just want like mostly healthy. Like I'll just take it semi-functional, that's fine. So I think some open questions around this are, so today, we have that one-to-one mapping between data encryption key and object in etcd. I think the main concern I had around some of the changes that have been proposed in the past with like using the key for some amount of time or other variations of basically less data encryption keys is what it comes down to, is that today, if you run the storage migration, right, which is part of the we have a SIG API machinery sub-project, which is a storage migrator, and just the general concept of storage migration, right, which is basically read all the data from the Kubernetes API and post it back to the Kubernetes API completely unmodified for all objects, right? And then look at the resource version of all the objects that are returned. For the objects that have the same resource version, you know that they were already up to date with the latest and greatest, and with the ones that do have a resource version changed, you know that they needed to be updated, and they were. But the gist of it is that is the process that sort of has to work correctly for you to rotate your keys, right? And it does today, right? If you do that, if you follow those steps today and you do the rotation dance, everything works fine. The approaches I've seen where like a deck is reused for some time had failure modes where they would be like, yeah, no, everything is up to date, but it hadn't actually done the rotation because it had cached the deck for some amount of time. I'm trying to remember exactly the flow. It's been so long since I looked at that code that it's a little flaky in my head right now.
Yeah, I think like some of the different options proposed as one was deck reuse, right? Like use it for a certain period of time, and then like if for 5 minutes, and then after that regenerate a new deck, and then start using that for encryption. And then I think there was also an option where someone suggested you can use a deck per namespace. So that was the second one. And then the third one was, rather than duration, use a certain deck for a certain number of operations. So like you say one deck is used for 1,000 encryptions, and then once it hits that, then you basically use another deck for the next 1,000 and so on, right? So like I think most of it was around reusing it, but how to reuse the context was just like there were different proposals: namespace, duration, counter.
Anish, could you bring up the Kubernetes repo so if we could try to find some of the old PRs? You might actually already have it linked. Yeah, so that if we scroll down, I think we had some good discussions here somewhere.
Actually, I think that might be in the issue. I think there was an issue link that I shared. This is also PR. Yeah, I think this was the one issue where a lot of things were discussed around deck reuse.
By the way, I've actually never understood what Mike was trying to say with this diagram.
Yeah,
I'm not saying there's anything wrong with what it is. I could never actually figure out what he was trying to get me to understand.
Yeah, the only thing I understood was there is a KEK that generates a local KEK and uses that for a period of time. So this is almost like bringing the encryption key from KMS to keeping it in memory or something like that, so that like it never has to worry about external calls.
So this is something I mentioned in the document too. So I was a little bit more cautious with reusing the keys. And then I kind of jokingly said, well, if we would use the deck to encrypt other keys, so it would kind of be a local KEK, this would be most probably fine. So I think this was just a diagram to show that you have a layer that is remote KMS, then you have a local KMS, and then you have the real data encryption keys.
Yeah, and I think what it gets down to is like if I do a storage migration, I have to be able to tell the system somehow it cannot use the local KMS. It has to go all the way down to the real KMS, get it to do work associated with that to make sure everything is up to date with the latest foundation, like the sort of the foundational keys that are being used to encrypt everything, and that's where you get like basically we're hitting one of the canonical problems of computer science, right? Which is cache invalidation, right? Like how do you know when the right time to invalidate your caches so everyone is up to date? And I don't know what I think that's my head at the bottom of this screen right now. Just scroll down in this. Okay, that was me, I think, talking about using Citadel to play around with stuff to, because one of the things that I think still was never defined is what is the actual cost of running a KMS? Like what is like the actual like latency and performance impact of just a KMS, right? And Citadel was like a perfect way to test that, because all it did was only ever have a local key encryption key that it held in memory. So it never made any network calls. So the only thing that you were measuring is if you have an API server and you have Citadel co-located with it running a Unix domain socket, what is the overhead of talking over that Unix domain socket? I don't think we ever actually found those numbers, because I think Alex left Google. It said thus no one really picked up that work. But I think that, sorry.
No, go ahead.
I was just saying that I think that would still be valuable for us to understand what the cost of using a KMS is, because today we don't actually tell anyone, right? Like we say KMS is the best approach, but one, we don't define all the failure modes, but we also don't even tell you if everything is working perfect, what is the actual cost of using one.
Yeah, I think two aspects of it, right? One is the round trip time. So basically like how long the operation takes, and then also the number of calls it generates. Like 100K cache size, I think with cloud providers, it's just, if you actually have 100,000 secrets, I think it's really hard to actually restart your API server and like not have things crashing or hitting rate limits. Unless the KMS plugin is keeping the encryption key in memory. Like if it's making network calls, yeah, I think it's just, it doesn't scale at all. And that is where if we reuse DEX in like some acceptable way, then at least like we can reduce that by a certain factor. Like if we use the same deck for like, let's say 1,000 secrets, then for 100,000 secrets, we still would only make 100 calls.
So here's a question, right? Like since we've been talking about a reference implementation, and I realize we only have a few minutes left. If we had a KMS implementation that internally generated a key encryption key, like locally, you know, went ahead and told the gRPC API behind it, the like Azure Key Vault or whatever, hey, I need you to store this for me and like let me get it back after some point, right? And then it was then going to locally use it, right? Like basically, is this a problem that can be solved with some amount of key hierarchy within the KMS itself, right? So it's even if we left the data encryption key purely one-to-one as it is today, if the KMS itself, when it did the encryption, stored some metadata about like, hey, I used this key encryption key. Let me fetch that back. Let me decrypt, like, let me make one decryption call to decrypt it back into its full state. Now I can decrypt all data encryption keys that are being sent over the gRPC API with this one locally. I don't have to make any network calls, right? And then it sort of becomes a KMS policy decision then, right? Like how much are you willing to use that key encryption key, right? So you could then basically say, well, I don't know, I can use it for some amount of time. I can use it for a certain number of operations. But I think that does significantly reduce the problem though, right? Like if that capability is in the KMS, or am I misunderstanding? Am I missing some scenario?
I would say that the only thing that we wouldn't have to tackle if we have a local KK would be to, like, today the users have control of the KK. If they want to create a new one or to do a rotation every like 7 days, they can do that on their cloud provider. But if we have a local KK, we'll need to define like how do we change it? So we will have to communicate, like have a way to notice that the KK on the server side change for us to change the local KK. I think that's the bare minimum that we should do to leave the users kind of under the control of the key.
I also want to raise that the reason why people want to use a remote KMS is because it comes with all the industry standards and all the policies and all the compliance stuff, right? So now that we're starting to have a local one, I don't know what that means for compliance and security concerns. Go ahead.
So is that any different than the fact that we already have a hierarchy with the data encryption keys, right? We, the API server, generate keys in a way that the KMS cannot influence. And we use an algorithm that the KMS cannot influence and a storage format that the KMS cannot influence. And then we just hand you the encryption key and say, you have to store this, give it back to me in a format that I can hold on to that's opaque, right? Is it any different than that? Because yes, you have your industry standard KMS that might be using like quantum crypto or whatever, but it's still limited. I mean, Christoph is laughing, but I'm sure, like, maybe it is. Maybe he's doing something cool or something really fancy.
Well, the HSM stuff, right? The hardware, yeah.
Right, yeah, it's using a secure enclave HSM.
Yeah.
Like, these are all very important and good things. But then what's actually left as the weakest link is the data encryption keys that we are generating in memory using Go code, not using an HSM, and then using them for the actual true encryption, right? So like if you were an attacker,
Sure,
and
but
you
it's
had
in memory, right? Now this local one is it on disk or in memory?
No, it would be generated in memory. Like, so imagine the KMS, it starts up, it generates one in memory, and it does one KMS call telling the real KMS, hey, I need you to encrypt this for me and give me the encrypted blob, right? So that way it knows what the encrypted payload is, right? And so when data comes in from the Kubernetes API server, it can figure out like, all right, like how did I encrypt this? Do I have that key now, or can I go back and get it from the real KMS, right? It's basically one level of indirection within itself, but it's always in memory, right? So it should always be able to come up with no state, come back up, generate a new key, and be ready to do encryption. But when it comes time to decryption, it has to basically warm up its cache using the real KMS. But the idea there would be is that cache could be over many, many data encryption keys from the Kubernetes API server, right? Whatever the policy is, whatever is okay for that plugin to do. But it's just one level of hierarchy separated, right? But it's within the control of the KMS plugin. Like basically today, what we're saying is the KMS plugin is just a pure conduit to the real KMS. And I'm saying it doesn't have to be that way. If we explore that as a potential choice, then like I want to be careful with the decisions we make in the Kubernetes API server, because we make them for everyone, and you don't really get a choice, right? Because today you don't get a choice about how we use data encryption keys in the format, right? That's not really great, and that's actually where some of the pain point comes in. Is like I have a bazillion secrets and they're one-to-one, and I'm calling, as Anish mentioned, if you make 100K decryption calls to your KMS, something's not going to work. Right, and maybe the KMS plugin can actually take a stronger role in making that, right? And I would feel much more confident in saying such a statement if there was a reference implementation that did the thing that we were saying, instead of like hand waving it.
I was gonna say, this is not like you should add this to the doc as in the another option. I don't think I saw it. This is new.
So definitely,
we're like over time. Christoph, you have something?
Definitely a local KMS is a huge advantage when we have maybe just one KEC or we have very few calls. But this is quite a big implementation, and I was curious, why don't we have such some batch calls where okay, I have a cache of 100K keys, send them all at once to the KMS and ask it to decrypt or encrypt it?
That
Why do
is
you have-
interesting. Maybe Anish and Rita can answer. Could such a is such a capability present in like Azure Key Vault? Could I give it a bunch of data at one time with maybe some schema for it to figure out like which bits are like, you know, like the delimiter or however like the encrypted data is separated, and could it decrypt all of them and hand them all back to me? I actually have no idea.
Yeah, as far as I know, you cannot do that. Like, I mean, you give it something like you give it the plain text and it'll just encrypt the whole thing, but you cannot give it like a bunch of data and say, can you just do all of the encryption at once and give me back the encrypted data?
Well, I think what sorry, go ahead, Christoph.
Yeah, but could we just, you know, send them like, okay, this is so the client, so we as the KMS plugin would set some ID and behind it the thing that we want to encrypt, and then the cloud provider would just encrypt it and return also like kind of a JSON object where you have the ID that we specified, and then behind that we would have the encrypted part. So we could encrypt several things at once and not have single calls.
Yeah, I don't think it does that. I
And
think
also it's highly dependent on the cloud provider, right? Like it, I would imagine even if you had a call like that, an endpoint that supports that, ultimately you'll still probably get throttled. There's always going to be a limit.
Yeah, I mean, I think at a high level, though, I think, Christoph, what you were describing is actually kind of similar to what we were just talking about, right? We're basically trying to build a hierarchy somehow. It's basically, where does the hierarchy live? Does the hierarchy live within the true KMS implementation, or does it live within the KMS plugin? And I think the problem is Kubernetes is trying to make a extension point that has to be basically the least common denominator of all the cloud providers and like PKCS 11 and the other encryption standards, right? Like everyone needs to be able to implement this gRPC API, because that's sort of what we want to happen.
Yeah, but we also specified the initial API, right? Where we said, okay, we send you, and we have two options, encrypt or decrypt. And could we just specify, okay, this is the new API where you can encrypt or decrypt a bunch of stuff, and then ask the cloud providers to implement it? No?
So I mean, so certainly the gRPC API could be expanded to have like a bulk encryption. Really, bulk encryption I don't think matters. I think it's bulk decryption we care about. Like your rate limited, like the Kubernetes API rate limits how fast clients can talk to it. So I don't really think that's the case here. It's like when I start up and I have to read the whole world, I need that to work, and I need to work every single time, right? In that case, if you had a bulk decryption capability, I think, yeah, that solves the problem. I just don't think any KMS that we currently have that is in use today supports such a capability where you send it not just a ciphertext, but a series of ciphertexts at once, and ask it to do all of the decryptions and then send all of the decrypted payloads at once. I just don't think that API exists.
Yeah, so this would be, so obviously your solution that you propose to Citadel and having a local KMS is obviously better, but for, I don't know if it would be a huge implementation effort. I just wanted to just ask if it wouldn't be just easier to change the API and say, okay, now we would like to have also a batch encryption, batch decryption things. And before we close out, one thing that's super important, we should always have boundary conditions, what we allow the users to do. For example, I looked up that you shouldn't use the when you're using ASGSIM, use it more than 2 million times. And for CBC, I tried to find it, but it was more esoteric. So there was no concrete hard number, which you should take to orientate. So I would be worried that the customer says, oh, fuck it, I need to be FIPS compliant, and it's enough when it's once a year or something like that. And then they would wonder that the database got hacked and that there's some leakage in it.
Right. I think, Christoph, what you're saying is no matter what, we have to make sure that if we're using something like GCM or whatever encryption mode we're using, we don't let the user have an option where they can go out of the safe bounds of that mode, no matter what. We guarantee that. And I totally agree with that. Yeah. Cool. I have to drop. Thank you all for the discussion.
Thank you.
Thank you.
Have a good
Bye.
rest of the day. Bye.